Hi everybody. All right, in this video we're going to look at what are called the basic differentiation rules, so aka the shortcuts. So in class today you got to practice with the definition of the derivative a little bit. We will revisit it later, but I would say that that's the long way to find the derivative. So eventually mathematicians found some shortcuts or some easier ways to find the derivative. So now we're going to get into those shortcuts. Okay, so the first three cases that we're going to look at, or the first rule, is called the constant rule. And this is where you would be finding the derivative of a constant function. So if you think about a constant function, like let's say the function is f of x equals 4, remember the graph of a constant function is a horizontal line. And remember that derivative is slope, so what's the slope of a horizontal line? Slope of a horizontal line is 0. So anytime you're finding the derivative of a constant, it always equals 0. Okay, so it gives us this rule right. Now, the d over dx is called the derivative operator. So this is saying the derivative of c, or of a constant, is always equal to 0. Okay, so back to my example, if the function is f of x equals 4, then f prime of x would equal 0. The derivative of a constant is always 0. Okay, now, our next rule is called the power rule. And let me just say, we will use this a lot. And eventually it'll just become second nature. You won't even have to think power rule, you'll just do it. Okay, so the power rule is a way to find the derivative of a function that's in the form of x to the n power. So as long as n is a rational number, then we can find the derivative, and it works like this. The derivative of x to the n power is always equal to n times x to the n minus 1, okay? So for instance, let's say our function is f of x equals x squared, then f prime of x would equal, we bring the exponent down in front, so it's n, which is in this case 2, times x to the n minus 1. So 2 minus 1 is 1. And then of course we'd probably just write that as 2x. Or, like in class today, our function was x squared minus 1 in our warm-up. And so when we had used the definition of the derivative, we had gotten 2x as the derivative. Well, now that is super duper easy because the derivative of x squared is 2x. And then the derivative of a constant, so the minus 1, going back to our constant rule, the derivative of negative 1 is 0. So you end up with 2x plus 0, which is essentially 2x. So that is super easy now to find that derivative. Now, there is a special case of the power rule. Okay, so what if we want to find the derivative of x to the first power? Well, let's just see how that works out. I'm going to try to squeeze it in the middle here. Let's just apply our power rule to that. So if we're finding the derivative of x, right now the exponent on x is a 1. Okay? So if we use our power rule, that would equal, we're going to bring the 1 down in front, 1 times x to the 1 minus 1 power, which would end up equaling 1 times x to the 0 power. And then if you think back to properties of exponents, any base raised to the 0 power is equal to 1, so that becomes 1 times 1, which equals 1. So anyway, long story short, if you're finding the derivative of x, it will always equal 1. Okay? All right, let's look at a few more examples using the power rule. So we want to find the derivative of each of these functions. So a is pretty easy because f of x is equal to x cubed. So again, using our power rule, f prime of x would equal, you're going to bring the 3 down in front, times x to the 3 minus 1 power, which will just simplify to 3x squared. So much easier than definition of the derivative. Okay, now, if you were ever dealing with radicals, like here we have the cubed root of x, you always want to convert radicals to fractional exponents. So let me remind you how that works. If you have the square root of x, that can be written as x to the 1/2 power. And if you have the cubed root of x, like in this case, that can be written as x to the 1/3 power. And there's kind of a general rule that says if you have the, let's say, nth root of x to the m power, that can always be written as x to the m over n. Okay? So for instance, let's say you had the square root of x cubed. That could be written as x to the 3/2 power. Okay? So just a little reminder back from algebra that radicals can be converted to fractional exponents, and that's what you want to do in this case because we've got to have it set up as x to the n power. Okay, so the first thing I would do here is rewrite the cubed root of x as x to the 1/3 power, and then we're going to apply our power rule. So g prime of x would equal, we're going to bring the 1/3 down in front, times x to the 1/3 power minus 1. Now, you're subtracting fractions here, so you need a common denominator. So g prime of x would equal 1/3 times x to the 1/3 minus, and we want to convert the 1 to 3/3 so that we have a common denominator, and we can actually subtract the fractions. All right, so we get 1/3 times x to the, subtract your numerators. 1 minus 3 is -2/3. Put it over your common denominator. Now, this is the derivative, but in terms of simplifying, we tend to not leave negative exponents when we simplify. So remember, to change a negative exponent to a positive, you find the reciprocal. So it would be like making this a fraction by putting a 1 under it and then flipping it. So it'll become 1/x to the positive 2/3 power. And then if I multiply straight across, this will become 1/3 times x to the 2/3 power. And you know, sometimes you will see fractional exponents left in simplified solutions, like on the AP exam. But sometimes they might be converted back to radicals. So if I convert my fractional exponent back to a radical, it would become the cubed root of x squared. Okay, so you might see an answer written like either way. Okay. Okay, in our third example, we want to find the derivative of y equals 1 divided by x squared. So again, remember, we've got to get it into this x to the n form, okay? So we're going to use our properties of exponents, and we're going to rewrite this as y equals, I'm essentially going to flip the fraction, which will change my positive exponent to a negative exponent, okay? And we can apply the power rule to negative exponents. Okay, so in this case, y prime would equal, we're going to bring the -2 down in front, times x to the -2 minus 1 power, which is going to simplify to -2 times x to the -3 power. And then we're just going to simplify. We want to get rid of that negative exponent, so we're going to find the reciprocal, okay? This would be like -2/1 times x to the -3/1. Sometimes this is confusing. Only x has a negative exponent, so we're only flipping the x to the -3. So it'll be -2/1 times 1 over x to the positive 3 now, because we flipped it. And then if you multiply straight across, you'll get negative 2 over x cubed. And we'll just leave it like that. This is simplified form. And we're good to go. Okay. So again, the calculus here is super easy. Sometimes it's the algebra that's difficult, dealing with all these different exponents, properties of exponents, fractional exponents, negative exponents, all that good stuff. Well, this rule can sometimes make finding the derivative a little bit easier. It's called the constant multiple rule. You might remember we had a similar rule for limits. If f is a differentiable function and c is a real number, then c times f, okay, is also differentiable. And the derivative of c times f of x is equal to the constant c times the derivative. So basically this is just saying that you could move the constant out front, okay, find the derivative of the function and then later multiply it by the constant. Okay, so for instance, when we look at our examples, y equals 2 divided by x. Well, just like in our previous examples, in order for me to use the power rule, I'd have to rewrite this as y equals 2 times x to the negative 1 power. So now what I can do, y prime would equal 2, that's my constant multiple, times the derivative of x to the negative 1. Okay, so essentially setting this up. So I'm just going to apply the power rule to x to the negative 1. So I'm going to bring that exponent down in front, multiply it times x to the negative 1 power minus 1. So this will simplify to 2 times negative 1 times x to the negative 2 power. And now I can multiply that constant. 2 times negative 1 is negative 2, x to the negative 2. And then the last thing in terms of simplifying, I want to get rid of that negative exponent, so this will become negative 2 over x squared. Okay. All right, let's do this next example. We have f of t equals 4t squared, all divided by 5. So honestly, you guys, this could be rewritten as 4/5 times t squared. Okay, so 4/5 is essentially your constant multiple. So when we find our derivative, we'll just bring that constant multiple down, and then we only have to derive or find the derivative of t squared. So again, using our power rule, we'll bring the 2 in front, times t to the 2 minus 1 power. Okay, simplify. We could go ahead and multiply the 4/5 times 2. Now remember, that's like 2 over 1 as a fraction. So when you multiply straight across, you'll get 8 over 5 times t to the first power, because 2 minus 1 is 1, and we're done. We're simplifying after that, so that's always nice. Okay, for our third example here, again, we have a square root or a radical. So before we find the derivative, we want to convert that to a fractional exponent. And then 2 is a constant multiple, so when we find the derivative, y prime, I can just bring down the constant multiple and then just derive the x to the 1/2 power, okay, using my power rule. So the 1/2 will come down in front, times x to the 1/2 minus 1 power. All right, so let's work that out. 2 times 1/2 times x. Okay, so we need a common denominator, so 1/2 minus 2 over 2. So, and I could go ahead and multiply the 2 times 1/2, which will simplify things because that's going to equal 1. So now I just have x to the, okay, 1 minus 2 in my numerator is negative 1 over my common denominator. All right, so then we end up with a negative exponent. So to get rid of our negative exponent, make it positive, we're going to flip it. And then we could, in the end, go back to radical form and get 1 over the square root of x. All right, moving on. few more examples using the constant multiple and the power rule. Okay, so again, for this example, we want to do some rewriting here before we can even apply the power rule. We want to convert our radical to a fractional exponent, so this would equal x to the 2/3 power. And then really, we could rewrite this as 1/2 times 1 over x to the 2/3 power, meaning 1/2 is a constant multiple. But I still can't apply the power rule because I need this to be in that x to the n power. But what I can do is flip it and make it x to the negative 2/3. And then I can actually apply the power rule. Okay, so now 1/2 is a constant multiple, so I'm just going to bring that down. And then I'm going to find the derivative of x to the negative 2/3 using the power rule. So we're going to bring the negative 2/3 down in front, times x to the negative 2/3 minus 3/3, because we need that common denominator. And you guys, you'll get used to that. Like a lot of these steps will become second nature, where you won't even have to write it out. You know, I'm trying to show you step by step here. But we'll use this so much that, you know, you'll just get used to it. Okay, now. Okay, subtract your numerators. So negative 2 minus 3 is negative 5 over your common denominator. And now we're just simplifying, so I can multiply the 1/2 times negative 2/3, which is just multiplying straight across. It'll essentially, well, your 2's will cross reduce, so let me see if this makes sense. It'll end up being negative 1/3. If that didn't jump out at you, when you multiply straight across, you'll get negative 2 over 6, and then that would simplify to negative 1/3. Okay, times x to the negative 5/3. But then remember, we don't want to leave negative exponents, so we're going to flip it, make it a fraction, flip it. Flipping will change our negative exponent to a positive, and then multiply straight across. And of course, in some cases, the fractional exponent might be converted back to a radical, so this would be the cubed root of x to the 5th power. So we end up with negative 1 divided by 3 times the cubed root of x to the 5th power. Whew, okay. Now again, eventually you'll get to where you can skip some steps, because right now you're probably thinking, wait, this is simpler than definition of the derivative, but you'll get faster with it. Okay, last example, this one's a little bit easier. What I want to show you here is the negative 3/2 is a constant multiple, because you could rewrite this as negative 3/2 times x. And so then when we find our derivative, just bring the negative 3/2 down, times the derivative of x, which remember we already talked about that, the derivative of x is 1, so this just ends up equaling negative 3/2. Okay, now, when you're finding the derivative of a sum or difference, you essentially can find the derivative of each term and then add or subtract them, okay? This is very similar to our properties of limits, where if you were given the limit of a sum, you can make it the sum of the limits. Same idea. If you're finding the derivative of a sum, you can just find the sum of the derivatives. Okay, so long story short, all you have to do is find the derivative of each term and then add or subtract. Okay? Here is an example. If we want to find the derivative of x cubed minus 4x plus 5, we just find the derivative of each term separately. Okay, so f prime of x would equal derivative of x cubed, using your power rule, would be 3x squared. Bring the 3 down in front, subtract 1 from your exponent. Okay, the derivative of negative 4x would just equal negative 4, which is a constant multiple, times the derivative of x, which is 1, and then plus the derivative of 5, which is a constant, is 0. Okay, so essentially you just end up getting 3x squared minus 4. All right, let's look at g of x here. Now the first thing I want to do though, with my first term, the negative x to the fourth divided by 2, I would rewrite that as negative 1/2 x to the fourth. Because remember, there is a 1 in front of x to the fourth, and then that way the negative 1/2 is a constant multiple. Okay, so now to find the derivative. The derivative of negative 1/2 x to the fourth, well, negative 1/2 is a constant multiple, okay? And then times the derivative of x to the fourth using power rule is 4x cubed, okay? Plus 3 is a constant multiple times the derivative of x cubed, which is 3x squared using the power rule, and then minus 2 is a constant multiple times the derivative of x, which is 1, and then we can just simplify this. So negative 1/2 times 4 is negative 2x cubed, plus 3 times 3 is 9x squared, and then minus 2 times 1, which is 2. And we're done. So those are super easy. Okay, and then the last thing we're going to talk about today are the derivatives of sine and cosine. I was going to take you through a proof of one of these, but it's a little lengthy. But let me just say that these rules come from using definition of the derivative, the long way to find the derivative. But if you do that, and maybe if we have time in class one day, I'll show that to you. If you find the derivative of sine of x, it actually equals cosine of x. And the derivative of cosine of x equals negative sine of x. So they end up being each other's derivatives, which is pretty cool. But since the video is already kind of long, let's go ahead and jump to the examples. So we want to find the derivative of each of the following. So in our first example, 2 times sine of x, 2 would be a constant multiple, so we'll just multiply that times the derivative of sine of x, which you now know is cosine of x. So this just ends up equaling 2 times cosine of x. Super easy. Okay, for b, again, first I would rewrite this. If you have sine of x divided by 2, that's the same as 1/2 times sine of x. And then that way, the 1/2 is a constant multiple. And so you can just multiply it times the derivative of sine of x, which is cosine of x. Okay, and then for c here, it's okay if you have a sum or difference. Remember, you're just going to find the derivative of each term separately. So remember, the derivative of x is 1, plus the derivative of cosine of x is negative sine of x. So you do end up adding a negative, which eventually I would just make this 1 minus sine of x. Okay, so we're going to stop there and practice this in class tomorrow. There are some additional rules that we'll be learning throughout the week. So try to keep up with them, okay, because they kind of build upon each other. So you want to make sure that you understand these before we add to it. And I will see you tomorrow in class. Thanks for watching.